Hey guys, welcome to 2019 Level 1 MCAT for Day 2. So I'll get into it. So question 1. Marcus, the math teacher, gives his class some clues so that his age can be calculated. He says when 60 is divided by my age, and then 12 is added to my answer, this gives the result of 40. So so for this question, we'll let let's say that his age is the number x. So basically when 60 is divided by this unknown number, which is x, so 60 divided by x, and then 12 is added to this answer, so plus 12, that gives us an answer of 14. And now we can rearrange to solve for this equation. So if we move the 12 to the other side, we'll get 60 over x is equal to 2. If we move the x to the other side, it becomes multiplied by x, so therefore 2x equals to 60, and hence you can find out that x equals to 30, which should be your final answer here, and this should just simply be a achieved question. Once again, as I was saying for my 2019 physics and 2019 calculus videos, I'm not sure of the marking schedule, so I cannot be 100% sure of what each question is in terms of grades, but I will do my best to give an approximation of grades based on past year papers. So B, solve the inequality 6 times of 2 minus 4y plus 4 times of 6y minus 2 is greater than 4 times of y plus 4. Alright, the first thing first, always in these questions, is you have got to expand out the brackets first. So we got 6 times 2 is 12, minus 6 times negative 4y is negative 24y, plus of 24y, 6 times 6y times 4 is 24y, minus 4 times negative 2 is 8, is less than 4y plus 16. Alright, so now we can simplify a bit more. So this negative 24y and this positive 24y, they cancel out, so that's gone. So 12 minus 8, that's 4, is greater than, 4 is less than 4y plus 16. And if we move the 16 to our side, then we'll get negative 12 is less than 4y. If we move the 4 to the other side, then negative 3 is smaller than y. Hence, y will be greater than negative 3. And that should be your final answer for this question. And once again, this could just be an achieved question here. Alright, solve the equation y plus 8 over y plus 2 is equal to y plus 6 over y plus 3. So in this case, we're going to use cross multiplication. So we're going to say that y plus 8 times of y plus 3 is equal to y plus 2 times of y plus 6, cross multiplication. So if we expand out the brackets, we'll get y squared plus 11y plus 24 is equal to y squared plus 8y plus 12. Alright, so now we want to solve the equation for y. So basically y and y cancel out. So we'll move the 8y to the other side, that becomes minus 8y. So 11y minus 8y is 3y. Move the 24 to the other side, becomes negative 24. So this equals to 12 minus 24. 3y equals to negative 12. So therefore our y will be equal to negative 4. Alright, so for this question, it could be a merit or achieved question. I'm not too sure, but yeah. So either one of these. So one of these questions should be merit. So either this question is merit or question B is merit. I'm not sure which one. In terms of getting achieved, perhaps if you set up your equation, you could get an achieved just for setting up an equation. But yeah, one's not too sure. The diagram below shows a sketch of part of the graph y equals to 10 plus 12x minus 6x squared. Tamara draws another line onto this graph with the equation y equals to 7x minus 15. Find the x values of the 2 points when the graphs intersect each other. So we want to find this x point here and this x point here. Alright, so the key features to note down is that when two graphs intersect, that means that their y values are equal. So this y, it will be equal to this y when they intersect. So when y is equal to y, we can say both of these is equal at our point of intersection. So we can say that 10 plus 12x minus 6x squared is equal to our equation of 7x minus 15. So now we want to rearrange this equation. Okay, so we can move everything to one side. We'll say that 0 equals to 6x squared, positive 6x squared, minus 5x minus 25. And now it's a matter of solving for x. Okay, so this should be an easy way to expand this. I think let's try this. So that should be your expansion. So let me double check that. So 5 times negative 25, negative 15. Yeah, that's right. So that will be your expanded form. So we have 3x plus 5 equals to 0, or 2x minus 5 equals to 0. 3x equals to negative 5. So therefore, in this case, x would be negative 5 over 3. And in this case, 2x is equal to 5. So in this case, x would be equal to x is equal to 2.5, so 5 over 2 actually. Alright, so both of these, this is the points where they intersect. So this point here would be negative 5 over 3, and this point would be 5 over 2. Alright, in terms of the grading for this question, this should be an extensible question for this question. Looking at the paper, this should be the extensible question. If you find both of the points, and in terms of getting an achieved could be up to here, perhaps, could get you an achieved. And for a merit, perhaps if you expand it factorize correctly, you'll get a merit. Yeah, somewhere along the lines. The equation of the straight line passing through the points 3, negative 3, and 7, negative 8 is given by h of y is equal to g of x plus 3. So we have a little simultaneous equation to solve here. So remember, x value is always on the left, y value is always on the right. So x value is on the left, y on the right. Alright, so this question, when x equals to 3, y equals to negative 3. So when y equals to negative 3, negative 3h equals to x is 3, so 3g plus 3. And we also have the equation, negative 8y is equal to 7g plus 3. Double check that, so negative hy, yeah. Okay, so this plus 3 and this plus 3 is the same either way, so we can just, actually, we'll keep it there for now, just in case. We have simultaneous equations here, so we want to make one in terms of the other would be preferable here. So, for example, I see here we have make negative 3h minus 3, move the 3 to the other side, divided by 3 is equal to g. So therefore, we can say negative h minus 1 is equal to g. So we can replace negative h, negative 1 in terms of g in this equation. So we can find for our, this is h actually. So we can find for our h value, okay? So in this case, we have negative 8h equals to 7 multiplied by negative h minus 1 plus 3. So now we will have negative 8h equals to negative 7h minus 7 plus 3. If we move the negative 7h to the other side, we get negative h is equal to negative 7 plus 3, that's negative 4. So therefore, your h value is equal to 4. And once you have your h value, it will be very easy to find your g value. So we can say, using this equation here, we can say negative 12 is equal to 3g plus 3. So therefore, if we move the 3 to the other side, we'll get negative 15 is equal to 3g. And hence, your g value will be coming out to be negative 5 there. Alright, just let me double check this on my calculator real quick. I know you don't have calculators during the exam, but I just wish to double check my answer, just in case. Simultaneous. So we have we have 4 and negative 5, that's correct. So if we find both of these values, that will get you an excellence grade. And in terms of getting a merit grade, perhaps just finding one value, so either or you get a merit grade. And to get an achieved grade, I'm thinking achieved grade. Perhaps one in terms of the other will get you an achieved grade. So writing one in terms of the other could net you an achieved here. Alright. Question 2. What is the value of 3y to the power 4 minus 5y plus 2 when y equals to negative 2? Alright, so we're just going to substitute y equals to negative 2 in this equation. So 3 times of negative 2 to the power 4 minus 5 times negative 2 plus 2. Alright, so negative 2, it's an even power, so it's going to be positive. So 3 times of 16. Double negative makes a positive, so plus 10 plus 2. And that should give you 48 plus 10 plus 2, which gives you 60. And let's just be an achieve mark here. Solve the equation 15y squared minus 4y minus 4 equals to 0. So we're going to be factorizing this equation. So finding something that multiplies to negative 4 and adds to negative 4 as well. Wow, okay. So you factorize and then you solve. So let me double check. Yeah, that looks right. So 5y plus 2 equals to 0, or 3y minus 2 equals to 0. So in this case, we'll have 5y equals to negative 2, so y equals to negative 2 over 5. And in this case, we'll have 3y equals to 2, and therefore y equals to 2 over 3. So we're getting both of these answers should get you, let me take a look. Interesting one. Could just be an achieve mark here as well. I think this might just be an achieve question. Find the values of y if 25 times 5 to the power of 2y plus 13 equals to 5y squared. So, okay, so we want to make everything the same base, and if we make everything the same base, we can remove the base and then solve for a quadratic. So 25 can be rewritten as 5 squared. So we'll do that. So we say 5 squared times of 5 to the power of 2y plus 13 equals to 5 to the power of, 5 to the power of y squared. When you multiply powers, you know that you add the powers, okay? So that's very important. You don't multiply the powers, you add the powers when you multiply, okay? So this is the same base, 5 and 5, so you can add these two powers. So you can say 5 to the power of 2y plus 15 is equal to 5 to the power of y squared. Okay, so this base is 5, this base is also 5, we can get rid of it. So we'll say that 2y plus 15 is equal to y squared. And then if we rearranged for 0, we can solve the quadratic. So we'll say y squared minus 2y minus 15 equals to 0. So what multiplies to negative 15 and adds to negative 2? So we have negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So those would be our two numbers. So we'll say that y minus 5 multiplied by y plus 3 equals to 0. So therefore, our y value equals to 5 or negative 3. Looks right. Okay, so for this question, I'm thinking, I'm actually thinking an excellence level grade, since there was a similar question to this last year, which was worth an excellence grade. So I'm thinking this should get you an excellence level grade. And in terms of an achieved, I'm thinking if you just rewrite the 25 as 5 squared, that might actually be good enough for an achieved. Maybe. Okay, no, actually no. In my opinion, if you add the powers correctly up to this step, that could get you an achieved. And if you can get a merit, perhaps writing up to this step could get you the merit grade. Alright. The plan of a rectangular classroom space is shown in the diagram below. If the perimeter of the tiled space is 192 meters, find the value of y. Note that the tiled space does not include the shaded carpet or cupboard. Alright, so this question, it is a bit confusing the way they worded it, but I'm thinking they mean perimeter as in this length here. And that's fine. Okay, we'll say it's a pretty arduous process. So let me see. So this whole length is 10y plus 5. And 10y plus 5. 10y plus 5 is 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 10y plus 5. Actually, I just realized something. This will actually be... Actually, this actually will be the exact same parameter as if I just did the whole revolution. Will it? 10y. Okay, I'll play it safe. Alright, so if this whole length is 10y plus 5, then this length is 2y minus 3, then this length has to be 10y plus 5 minus 2y minus 3, which is 8y minus plus 2. No, it's plus 8 actually. What am I doing? 8y plus 8 plus, yeah, that's right. So this is 8y plus 8 plus 3y plus 2. Yeah, okay. This length is 3y. Okay. Gosh. This length is 3y plus 2. And this whole length here is 5y plus 1. Which means that this length here has to be 5y plus 1 minus 3y plus 2. And that gives us 2y minus 1. Okay, so this length is 4y, this big length is 10y plus 5, so this length has to be 6y plus 5. And same goes for here, this length here has to be 5y plus 1 minus the y here, so this is 4y plus 1. Alright, so now we have our equation, so 8y plus 8 plus 3y plus 2 plus 2y minus 3 plus 2y minus 1 plus 6y plus 5 plus y plus 5y, just add them together, plus 5y plus 4y plus 1. Okay, hopefully I didn't make any mistakes here, and that equals to 192. So we can group the like factors. So 8y plus 3y, 11y, 13y, and plus 2y again, 15y, 21y, 26y, that's 30y. And then we'll add the numbers together. So 8 plus 2 is 10, minus 3 is 7, minus 1 is 6, plus 5 is 11, plus the 1 here is 12. So 30y plus 12 equals to 192. 30y equals to 180. So therefore y equals to 6. So that would be your final answer for this question. And this should be a merit level question if I'm not mistaken. In terms of getting an achieved, I'm thinking if you can set up an equation but solve, just setting up the equation just gets you an achieved, perhaps. Alright, if t equals to y squared plus y plus 1, find an expression for the area of the tiled space in terms of t. Alright, so we want an area of the tiled space. The area of the tiled space is the area of the whole rectangle. Okay, let's drop this out. We don't. Not necessary anymore. Right, so the area of the tiled space can be rewritten as the area of the rectangle minus the area of carpet minus the area of, I would say this is carpet and this is cupboard. So area of rectangle minus the area of the carpet minus area of the cupboard equals to area of the tiled space. Alright, so we can model this equation. So we can say 10y plus 5, 10y plus 5, oh gosh, sorry guys, 10y plus 5 multiplied by 5y plus 1 is equal to the area of the rectangle. So we can say 50y squared. 5 times 5y is 25y plus 1 times of 10y is 35y plus of the 5 equals to area of the rectangle. Okay, so now area of the cupboard is 4y times y, and that equals to 4y squared. Area of the carpet is 2y minus 3 times 3y plus 2, so 2y minus 3 times of 2y 3y plus 2. So this equals to 6y squared, negative 3 times 3y is negative 9y, plus the 2 times 2y is negative 5y minus 6. Okay, so if we add the area of the cupboard and the area of the carpet, that equals 10y squared minus 5y minus 6. We want to do the area of the rectangle minus the area of the two shaded blocks. So 50y squared plus 35y plus 5 is equal to, not equal to, sorry, is minus of the 10y squared minus 5y minus 6. Very important to not forget the brackets, because that makes a big difference, because once we expand the brackets, a double negative makes a positive, so negative of negative 5y is positive 5y, negative of negative 6 is plus 6. And that's the area of the tile space. So 40y squared plus 30y plus 11 equals to area of the tile space. Yeah. So if t equals to y squared plus y plus 1, find an expression for the area of the tile space in terms of t. So first things first, we need 40 y squareds, okay? We need 40 of these y squareds in order to compensate for 40 y squared. So we do 40 times of y squared plus y plus 1. We'll get 40 y squared plus 40y plus 1. And that's 10 in terms of t, okay? Okay, that's interesting. 40y, so we say 20t is equal to 40y squared plus 40y plus, oh, that's 40, sorry. Plus 40. Okay. Okay, so we're definitely going to have 20t something. 20t. And we still need, and that's a difference of 10y plus 29. 10y plus 29. Wait, sorry, just hold on. Did I do something wrong here? Sounds too difficult to be right. Minus 9y, minus 5y, yeah, that's right. 3y plus 2. Actually, this is not 20t, this is 40t, my bad. Far out. Oh, okay, I see what I did wrong. So 35y plus 5y is not 30y, it's actually 40y. Wow. Okay, this makes this a lot more easier. Okay, so 40t equals to 40y squared plus 40y plus 40. So we can say that area of the tiles equal to 40t, and that equals to 40y squared plus 40y plus 40. However, there's only a plus 11 here, so we need to subtract 29 at the end in order to make this true. So 40t is equal to 40y squared plus 40y plus 40. However, we only want 40y squared plus 40y plus 11. 11 is 29 less than 40, so we say area of the tiles is equal to 40t minus 29. And that will be your final answer here, which should get you an excellence grade. In terms of getting a merit grade, maybe if you can set up your equation for the area of the tile. So setting up your equation for area of the tile should be a merit. And if I think, if you can find all three of these areas, correctly should be achieved. Alright, once again, apologies for not adding correctly. My bad. Yeah. Question 3, g equals d squared minus 2f. Give the equation for d in terms of e, f, and g. So we want d in terms of e, f, and g. So that's, if we move the 2f to the other side first, we'll get g plus 2f is equal to de squared. So therefore, we want d in terms of everything else. So g plus 2f divided by the e squared should give us the equation for d. And that's an achieved grade here. Alright, so jz squared minus 16x squared equals to 5y squared plus 25wz squared. Given an equation for z in terms of w, x, y, and j. So we want the z in terms of everything else. So once again, we want to move this separate terms to the other side. So j z squared minus 16x squared minus 5y squared equals to 25 wz squared. So we want to group all the z's together on one side of the equation and leave everything else on another side of the equation. So we take this jz squared and move it to the other side. We'll get negative 16x squared minus 5y squared equals to 25wz squared minus jz squared. So now we can take the z squared out of the bracket and put it like factorize equals to z squared 25w minus j. So now we can move the 25w minus j to the other side. So 16x squared minus 5y squared divided by 25w minus j equals to z squared. And finally, we can square root both sides in order to find our final answer. So 16x squared minus 5y squared over 25w minus j, square root of the whole thing should give us our equation for z. And that should be your final answer, and this should be a merit level question. In terms of an achieved, if you can able to factorize up to here, I believe that should get you an achieved. Alright, simplify as far as possible. 5y squared minus 25y over y squared minus 25. So in this equation, we want to find a like factor and then cancel it out. So in this case, we have y squared and y. Y is 5y is actually a common factor, so we can take 5y, factorize 5y. So 5y times of y minus 5 over y squared minus 25. Alright, so y squared minus 25, that can be rewritten as a y plus 5 times of y minus 5. Because the minus 5 and the plus 5 cancel out the y, so you're just left with y squared minus 25. So 5y times of y minus 5 divided by y plus 5 times of y minus 5. So this y minus 5 cancel out, so this equals to 5y over y plus 5. And you cannot simplify any further than that, so that would be your final answer. And just to note down that y cannot be 5, because negative 5, sorry. Y cannot be negative 5 because that makes the denominator 0. So in terms of grades, could be either a merit or achieved, maybe a merit for this question. And if you factorize either the top or the bottom, that should get you an achieved. Alright, so write 10y minus 2 over 5 plus 4y minus 5 over 4 as a simplified single fraction. So in order to do this, we want to make the same denominator. So we have 5 and 4, we want to make the same denominator. The lowest common multiple of 5 and 4 is 20. So if we say 20, if we multiply 5 by unknown, we say 20. So 5 times 4 is 20. So we say 10y minus 2 times of 4 plus of 4y minus 5 over 20. 4 times 5 is 20, so multiply the top by 5 as well. So now we can simplify. So we say 40y minus 8 over 20 is plus of 20y minus 25 over 20. So now we can add the fractions because common denominator. So 60y minus 33 over 20. And that should be that should be good enough as a simplified fraction. And this could be an excellence of a question, actually. That's unusual, but this could be an excellence, because considering there should be 2 excellence questions and 1 big question, if I'm not mistaken. Okay, so let's say this is an excellence level question in terms of getting it achieved. So line 1 would be achieved, and line 2 would be merit, I think. I'm not sure. I'm not too sure on the grading, but yeah. Find the value of W so that the area of the right angle triangle has the same value of the area of the rectangle. Yeah, so this is definitely an excellence level question. So we want to say that the area of the rectangle is equal to the area of the triangle. Area of the rectangle equals to base times height. So area of the rectangle is equal to 5W minus 14 times of W, which equals to 5W squared minus 14W. Area of the triangle is equal to half base times height. So area of the triangle equals to 3W, just one half of 3W minus 8 times of 4W minus 4. So area of the triangle equals to 1/2 of, we'll expand first, so 12W squared minus 32W minus 44W plus 32. And now we can simplify even more. So area of the triangle equals to 6W squared minus 22W plus 16. And we know that the area of the triangle is equal to the area of the rectangle. So we'll make them equal to each other. So we'll say 5W squared minus 14W is equal to 6W squared minus 22W plus 16. So we can say 0 equals to 6W squared minus 5W squared is just W squared. 22W plus 14W is minus 8. Minus 8W plus 16 is equal to 0. So now we can expand. So we can say that 0 equals to W minus 4 times of W minus 4. So therefore our W should equal to 4. Find the value of W. So that's done. We found the value of W, and this should be an excellence level question. In terms for a merit grade, finding both area of the rectangle and area of the triangle could get you a merit grade, and finding just one of them could get you an achieve. So both for merit and just achieve for one. Alright, so thank you for watching this video on the Level 1 2019 Day 2 MCAT. I hope you enjoyed the video, and I hope to see you all in the next one. Thank you. Bye.